For the thousands in attendance and the millions watching around the world, ladies and gentlemen, let's get ready to Python. He needs no introduction. He's the people's champion from Chicago, Illinois, presenting Reinventing the Parser Generator, David Beazley.
All right. Thank you very much. Where were you when I went up for tenure, by the way? All right. So we're gonna talk about parser generators in here. Also, I have to apologize. Have a cold, so if my voice kind of drops out, deal with that. Parser generators. Well, we'll start this off. I think the one thing I would start with is that programming is basically magic, if you think about it. And a big part of programming involves different levels of abstraction, basically. You take problems and you try to, figure out ways to solve problems, and it, involves things like naming things and data structures and functions and objects. But at some point, you're just going to exhaust all the possibilities of that, and you're going to need to go further than objects or something, right? I mean, it's like where do you go from there? You could jump into the land of Python magic methods. Python gives you great flexibility and sort of modifying the environment there. So you can do magic methods. I don't know, if people get angry with all your magic methods, you can deflect their anger by just calling all of those dunder methods, right? So, like mispronounce it. Then they're going to be angry about that, and you can. Okay, so you can do magic methods. But you might take it kind of a step further than that and get into what I guess would describe as linguistic abstraction, which is basically making your own programming language, or your own language related to the problem that you're working on. And there's a lot of history of this, involving things like mathematical notation and programming languages and things like SQL and config files and hardware description languages and all this stuff. So, there's certain problems where that really, like you try to make a language to kind of match the problem, and in doing that, you're trying to simplify the problem. The big problem is, how do you do that? Just as an example, let's say, I don't know, you made your own programming language and you had statements like that. How do you parse that? If I were to ask you, okay, take that code and break it up and parse it and understand it, that turns out to be a pretty non-trivial problem. This is more than just sort of string splitting or string partitioning or something like that. There's basically the problem of breaking that up into tokens. So recognizing that A is an identifier, and you have numbers and symbols and so forth. So there's kind of a tokenizing process. There's also just the problem of recognizing sort of the grammar of this thing. What is this code, what is it exactly? And so there's kind of a notion of a grammar for what a program is. You can say, well, program is a bunch of statements, and well, what's statements? Well, statements are many statements followed by one statement, or a single statement, and then you can ask, well, what are the different statements? There's assignment, there's printing, there's expressions. Suddenly this turns into a sort of a very non-trivial problem. And then even if you kind of get past that, you run into all these problems of even if you could break all this code apart, what do you turn it into? What's the end result of this thing? And you might end up building things like abstract syntax trees or other things, but it's a highly kind of non-trivial problem to get into that. If you ask coworkers or something, you say, well, how do I solve this problem? One thing that they might direct you to is they would say, well, go read the Dragon book. This is the famous. I modified it a little bit, but there's the infamous Dragon book. This is something that you give to students if you want to make them cry or something like that. Because if you go in that book, the whole book basically looks something like that. It's very dense, very mathematical. You'll walk away from that and just head spinning. And the truth of the matter is basically for doing parsing, most people turn to tools. This is this is a well kind of trodden area of CS. People have written, tools to do parsing and tokenizing. Some of the sort of more classic tools for this are lex and yacc on Unix. Yacc was developed in kind of the early 1970s. Lex is kind of in the same ballpark. And really kind of the idea there is that they have you describe your language in kind of a higher level, maybe something like this, where you write out your grammar, and then you run it through a code generator, and then you get a bundle of C code or something, and then you take that and compile it into your program. Now, this is not, these are old tools. It turns out that Python works this way as well. I mean, this is maybe a little bit obscure, but if you go into the Python source code, you'll find that its parser is basically automatically generated from a file. I don't know whether people have really seen that, so I thought I would just kind of show you that real quick. So this is the C Python distribution here. Essentially, if you go into a directory there's like a grammar directory. You can find a file called grammar, which is like a high-level description of what Python syntax is. If you look at it, let's just take a look at it there. You will get this thing saying, okay, well, this is the grammar for Python, and it's a little description, guide for how to change it, and you'll find this kind of description of what the grammar is for Python, and it goes on for a little while. There'll be a quiz on reading this later on. But then what happens with this is this grammar is automatically turned into C code to make Python's parser. The tool to do that is this thing called pgen. I don't know how many people have done pgen before, probably nobody. It actually predates Python itself. It's actually one of the first files ever written for Python, when it was first created. So there's been versions of this that go all the way back. And what you do on that is you feed it the grammar, and then you give it some output files. You give it a header file and a C file, and essentially you run that, and you get some C code, and then if you want to shatter your head, you look at that C code. No, it's like, if you look at it, this is what it looks like. It's not meant to make any sense. I mean, it's a lot of data structures and other things, and so through some kind of magic that basically creates the Python grammar or the Python parser. So this is something that's commonly done with these. If you want to make a programming language, you will often use parser generator tools, and there's a lot of these tools kind of floating around out there. pgen's not the only one. Now, having shown you that, one of the things that really inspired me, this is kind of early on in my Python career, so I went to the 7th International Python Conference. This was in 1998. And at the conference, John Aycock, who I think he might have been a grad student at the time, he's currently a professor up in Canada, he gave this talk about making little languages in Python. And it was really this awesome talk because a big feature of it is he did this horrible abuse of doc strings. I actually remember when he gave the talk, everybody kind of groaning in amazement and also kind of maybe horror at the same time. But the idea was that he had Python code where just embedded right in the Python code in doc strings, he had the grammar. And then his tool just magically made a parser. And it was really neat because you didn't have to, it wasn't like a code generator. You didn't have to make separate files. It wasn't like really complicated tooling or anything like that. And I ended up sort of copying that years later for a separate project. So I have this project called Ply. It was basically created in 2001 for teaching a compiler's course. And it was kind of a mash of sort of yacc and this Spark toolkit. For various reasons, I didn't want to use Spark because I was very interested in this very specific parsing algorithm, which is this LALR1 parser. Don't worry about what that is, but it's I wanted to implement that algorithm, and so coded this tool up for teaching the class, and without getting into too much tutorial on that, I thought I would actually do just an example of what it looks like to use a parser generator tool. These tools are basically kind of insane magic if you ever get into this part of sort of computing. And this is going to be no different, but let me do a little example of what it looks like to use this ply tool. Okay, so this is going to be my ply demo. I typed in a few things in advance here. So the thing we're going to try to do is maybe parse that code that I had on the slide earlier. You know, the A is 3 times 4 plus 5, and then print A. And essentially, there's two facets of this that we have to worry about. There's essentially a set of tokens, and those are like the individual words that we're going to recognize, or the individual symbols. And then I've got this grammar at the end, which kind of defines the valid kind of syntax of what this thing is. So to use a parser generator tool, like this ply tool, okay, I'm going to import this function lex, and essentially what you have to do is write out a specification of what is it that we're doing here. So one of the things that we have to write out is just tell it what tokens we're recognizing. Part of what you're doing here is you're sort of teaching the parser generator, like, what are the valid just, symbols that are going to appear here. So we're sort of writing out kind of a list of the symbols. Okay, start with that. And then what you have to do with that is you have to sort of teach it what these symbols are, and so that is going to involve essentially regular expression. All good problems are solved with regular expressions, right? So what this ply tool would, like, one of the ways that it works is you could write out strings, and you could prefix the string with like a lowercase t underscore, and it would just understand that as being a token specification. Now, if you must know how this is working, by the way, essentially ply is doing a bunch of introspection hacks, where it's like looking at the environment, and it's like basically defining tokens based on whether it sees like a t in front of your variable. That's an idea that was copied off of this Spark toolkit, so kind of appropriated that. So you write out your token, and then if you want to make a lexer, you do this step. You just say lexer equals lex, and then somehow through magic that makes a lexer for you. So here's how that's going to work. Okay, first of all, I'm getting a little warning about errors, and I'll talk about that in a second. But essentially, what you're going to do with the lexer is you're going to feed it some input. I don't know, maybe you feed it some symbols like that, and then you would do a for loop on it. And what it's going to do is break up the input into a bunch of tokens. So it'd come back and say, okay, well, there's your tokens. You have an ID, which is A, and you have equal sign, and num, and times, and num, and plus, and so forth. Essentially, it's trying to solve like a horrible sort of regex problem for you in a sort of simplified way. Now, there are some problems. One thing that you should probably not do is ignore warning messages. I kind of ignored that warning, It's like not supposed to ignore warnings. The problem there is that you might run into input that doesn't work right. Like, I just changed the input there to have some spaces in it. Turns out if I try to do that, it basically blows up saying, well, what are you doing? I got an illegal character like a space, and then it just dies. One of the things with tokenizers is that you have to basically teach them like the entire world of input. And if you don't do that, they just give up. So that warning message is essentially telling me that I needed to add like an error function in here. What you do in an error function is you, I don't know, maybe you do some kind of recovery, saying, okay, there was like an illegal character in there. And then you get the option of what to do. Maybe you do like a skip ahead. Okay, so we're going to do some recovery to kind of skip. We'll try it again here. Okay, now the thing is sort of staying alive, and I'm getting a lot of error messages sort of saying, I get a lot of white space. Ignoring that, these tools often provide techniques for that as well. Turns out that this ply tool, you can give it like a set of ignored characters, for instance, and then it will just discard any of those from the input. Okay, let's try that. Okay, so you're getting rid of illegal characters. Turns out that there's still other kinds of weird problems with this. writing like lexers and parsers is kind of a non-trivial thing because there's a lot of weird corner cases. One of the corner cases here is that it turns out that parsing that, like tokenizing that print statement doesn't actually work quite right. If you try that, let's just check it out here. You're gonna find that it does not recognize the print keyword. I mean, most languages, they have like a keyword for print or something. And what has happened here is that this thing has misidentified that print. It's a little bit subtle, but in the rules up here, I basically have a rule for like an identifier, and then I have a rule for print, and the problem is that print and that other rule are kind of in conflict with each other. Like print is a valid identifier, so they're in conflict. You might think that you could fix that by maybe moving the print first or something. You could say, well, I'll move that first and maybe make that more important. It turns out that does not fix the problem either. It's like if you come down to this print thing and try it again, it's still not picking up the print, basically. And so in order to fix that kind of stuff, you have to kind of take extra steps. One of the things that this ply tool does is it allows you to write functions that match tokens, where you embed like the regex in a doc string like that. Okay, so this is this horrible abuse of doc strings, where you'd say, okay, well, there's a function with the regex doc string, and then in the function you could do an explicit check, and you could say, well, if it's print, then let's like flip the type of the token to print and return it back. Okay, so you're doing a little bit of a hack there to do that. Now what's going to happen here if you try print? Well, let's try tokenizing it. Now it comes back and it says, okay, now I got print and I got ID and so forth. So, and tools allow some of these kind of customizations where it's like, okay, you can match things, but then do special cases and some other things. Let's see how people are doing out there. There'll be a quiz on this later on here. Some of the other things in tokenizing, by the way, you could put functions on some of the other symbols, like this number rule up here. You might turn that into a function. One of the things that you might decide to do there is if you tokenize it, maybe you want to convert it into an integer just as soon as you see it. And, it's like instead of leaving it as a string, you could basically like int convert it and then return it back. That might be something kind of convenient later on. So when somebody sort of tokenizes this thing, it essentially has tokens that are already sort of converted into numeric value. Okay, so that's part of using one of these parser generators. Kind of the ply tool kind of works like that. You write rules out, write some functions, and so forth. You've only really done half of the problem, though. It turns out that this grammar portion is also sort of magical. In order to deal with that, there's a separate component that you work with which is this yacc component. By the way, yacc stands for yet another compiler. If you're realize I've not defined the acronym for that, but that's what that stands for. And essentially what you do with this yacc tool is you write functions that match different grammar rules. So let me describe what I'm doing here. What I'm doing to start is I'm writing a function that just says, what does it mean to have multiple statements? And in the doc string, I'm writing out this grammar rule. I'm saying, well, multiple statements is multiple statements followed by a single statement. It's recursive, so you have to kind of wrap your brain around that a little bit, but it's saying, well, multiple statements is multiple plus one there. I'm not going to define what I put in there yet, but you start writing out your grammar kind of like this. You would say, okay, well, that's multiple statements. Well, what does it mean for a single statement? Well, you have a rule like that. You would say, okay, well, statements could either be a single statement or it could be multiple statements. And essentially, you're going to go through this grammar, kind of doing this. Now for this part of the grammar, you would say, well, what kind of statements do I have? Well, this first one looks like an assignment statement. So the grammar rule for that is that you have a statement that goes to like ID equals expression. Like name equals value, basically. Okay, so you're writing out grammar rule. Now you have a print statement. So the rule for a print statement is you have the word print and then parentheses, followed by some like expression, basically. So expression could be some kind of mathematical thing or something. So you're kind of going through this grammar and turning these into functions. You're going to do the same thing for expression down here. So you have an expression for like a binary operator. This is essentially like plus or minus kind of thing. Okay, so maybe you have expr plus expr. Start with that, and then you have some other cases down here where it's you have like an expression for a single number. Basically, an expression could be a number, and then you have an expression for like a variable lookup. Because you're gonna go through your grammar and kind of fill this out. This last that should probably be a def there. Okay. This last part is an expression for grouping. Okay, so you write out your grammar like that. Just as a note, by the way, writing out grammars is a pretty non-trivial thing to actually figure out the grammar for a programming language. So I don't want to gloss over that and say that's just like totally easy what's going on there. But this is, it's a fairly non-trivial thing. But you're going to write out, you have your grammar basically in functions like that, and then you take this sort of magic leap where you just run like yacc on this thing, and like somehow this produces a parser for you. Okay, so I'm going to run that. And it's going to come back with some mystery. First of all, it comes back with a warning message about a missing error function. We can ignore all the warnings, right? And then you get a message about shift-reduce conflicts. And it's like, what is that? Again, I'm going to ignore that for the moment. So they're just warnings, right? They're just warnings. And how this is supposed to work is that you would say parser parse, and then you give it some input. And it's supposed to parse your input somehow. Okay, so you say like parse a equals 3 times 4 plus 5. Now, at this point, basically nothing happens. It's like, okay, that was super anticlimactic, right? It's like, okay, nothing happens. The only time that you'd be able to determine anything happening is if you actually gave it like invalid input or something. Like if you said a equals 3. It would suddenly come back saying like, well, okay, I don't know what you're doing. What is this extra equal? I don't know anything about this extra equal sign. So what's going on there? All this thing is doing at this point is like, is it valid syntax or not? It does nothing else. And in order to do more, you basically have to teach this grammar to do other things. What you do in these functions, by the way, is you usually take some kind of action. Like in the number thing, you could say, hey, I got a number. If you printed out a value, what would happen when you parsed that or recognized a number is you would see that function fire, basically. Like if you did a parse, you'd see the thing saying, hey, I got a number. So it says, I got 3, I got 4, I got 5. Those rules are essentially like callback functions. Maybe it's not, like if you've done callback functions with networking or GUIs or something like that, it's kind of the same idea. These are basically functions that get triggered when the parser recognizes things. And then typically what you're going to do in there is build some kind of data structure. Now, the kind of thing that you might build in here is maybe like a tree-like structure. This is going to look a little strange, but I'm going to make tuples in these different rules. We'll just see what happens here. Okay, so I'm making basically data structures of tuples. What's going to happen is these things are basically going to propagate in the parser. Okay, so I'm making some tuples. Actually, for grouping, I don't need to do that. Okay, so just as a little description of what's going on here, this P0 is sort of the result of parsing, and the thing on the right is where you're getting it. So this is saying, oh, the result of a group is the result of whatever this second item is there. Left paren is the first item. So you put in these rules like that. Let's just kind of continue up the thing here. Here I'm saying you're printing the value of an expression. Here you're assigning the value of a variable. Again, the P3 means the expression part, and P1 means the ID part. And you start filling in the grammar with things like this. Okay, so here a single statement is a list with a single statement in it. Return. It's not the return statement. Apologize for that. Again, there will be a quiz later on here. Okay, so if you put in rules like that, if I've done my job right, and I'm not sure that I have, what the result of this is going to be is when you parse something, you're going to get like a little like structure of tuples like that. It's basically saying, hey, you're assigning A, and the value of A is the times operator, and you're taking 3 and you're multiplying that times 4 plus 5. One thing that you may subtly notice about that is actually not the correct mathematical calculation. You're not taking 3 and multiplying it times 4 plus 5. That is actually what that warning message is with the shift reduce, is that you have an ambiguity with operator precedence. So these parser generators often have rules for dealing with that, where you can teach them rules about operator like importance and precedence and stuff. So you can put a specifier in like that, maybe run this thing again, and then it will start doing things more correctly here. It's like, okay, now you're doing a plus, and it's 3. It's the result of 3 times 4 plus 5. I don't want to get too bogged down in the details of this, but one of the things that I want you to observe is that we're basically using Python as kind of a domain-specific language in a way. I mean, we're sort of abusing Python syntax to do a parser generator, and it's kind of an interesting way to do that. This is very much what this Spark tool was doing. It's very much what this Ply project is doing. And I guess some comments on this. This Ply tool, it actually gives me sort of great sadness, to be honest. One of the issues with this Ply tool is it actually predates a lot of interesting Python features. It predates like the iterator protocol. There are no decorators. There were no new style classes or anything like that. It was actually written in somewhat great haste when it was first created. It was made on a machine that was only 200 megahertz. So it had to take some coding shortcuts to deal with that. There's a lot of heuristics on source code inspection and other stuff. So the code is sort of insane. And to give you some ideas on that, this is typical of the code that you find in there. The reason that I put this up is I'm especially proud of this little bit at the end. I'm doing a for loop, and I'm incrementing the variable. Why? Like, I put this up because I would like to just lay claim to that being the Beazley pattern if I need to have like a name on it. Okay, so I found stuff like that. This is also kind of an interesting thing. How many people have a GitHub profile that looks like this? Don't be ashamed here. So I got a bug report 2 years ago from somebody. This was basically their GitHub profile. One patch for Ply. They basically found a 15-year-old critical bug in Ply. And in finding it, they actually found like the offending line of source code, which is truly remarkable. I can only think that that's why there's nothing contributing up to that point, because it took that long. And you're like, okay, what is this 15-year critical bug? Well, it's doing math correctly. They found like this case where you could do things like -3 minus 4 gives you 1, and it's like, that's not right. I mean, it's like that's not how that happens. But the reason I put that up, people like to look at GitHub things as like kind of score or something. Got a high score on GitHub. That was probably the most significant bug I've gotten in the Ply project in like 10 years. So read that. Take whatever you want from that, but that was sort of amazing. I did not put the person's name on here because I don't know whether this is a badge of honor or shame. I don't want to, kind of delicate there. And then there's been some other projects out there that have actually tried to make this Ply project respectable. And the problem is I don't want it to be respectable. Getting kind of in the end here, I actually want the project to die, actually. So, one thing that I kind of did recently is I had this, like, why don't I just put an F string in it? Just kill, like, all previous versions. And then just go crazy with some new features. There's a whole bunch of new stuff you can do in Python. Like, you can rely on the fact that dictionaries now have definition order preserved. Or you can use, you can write classes that monitor subclasses. There's kind of this init subclass thing that's pretty cool. You can still use metaclasses. I mean, they're kind of even more magical than they were before, but you can do some things with the definition environment that are pretty interesting. There's types. Yeah. Well, I think that types could be magic. I don't know. That's a whole different topic. Okay, so yeah, you could probably use type annotations for stuff. And kind of playing around with this, so I have a sort of a second version of the Ply project that explores some of this with flagrant disregard for anything probably decent, basically. But let's do a little demo of that. So the Ply project, or the Sly project, the way that works is it does actually go to more of a proper kind of object-oriented technique. So you do define, what you're going to do is define a class that inherits from lexer, and you're going to define kind of a token set. So you'll define what your tokens are, like that. Okay, so there's your tokens, and then it dispenses with the whole T thing. Okay, so you can take your class, kind of write out your tokens like that, and you basically have a lexer at that point. So what you can do is say, okay, my lexer is my lexer. All right, so you do that, and then if you want to tokenize something, you can say for token, lexer tokenize. Is anybody disturbed yet? A little bit? Yeah. You're probably disturbed by the lack of quotes and the. Okay. So you get your tokenizer like that. It still suffers from some of the same problems as before, like the print thing down here. That is still an issue. You have the problem that being misrecognized or not found, but that's actually really easy to fix because you can teach identifiers that if you see print, actually you don't need the quotes there. You can just turn that into the print token. Okay, so you can do things like that. You can also okay, so now it's basically saying you've got print and so forth. You can also attach functions to things. So like if you wanted to have numbers converted, you can do that too. So what's going to happen with that is if you did parse some numbers like a is 3 plus 4 or something, you would see those numbers basically being parsed. Oh yeah, I didn't do the ignored characters yet, so let's teach it that too. Okay, so it's kind of like the old tool. But a lot of it is sort of much more, I don't know, it's sort of much more compact and sort of much more elegant in many ways there. The parser component of it is also kind of an interesting idea. The way that works is you're going to make a kind of a parser that looks like this, and you're going to write functions. Okay, so you're going to write a function statements like this. So you kind of write functions that match the left-hand side. But I have to admit I did get rid of doc strings. People really did not like the doc string part of the Ply project, and it's like, all right, I'll give you something better than a doc string. So I'm going to give you the underscore decorator. It's the closest thing that I could come up with to look like Perl without actually being Perl. Okay. So yeah, I know people are really going to not like that here. Okay, so what you would do is essentially write like something like that. You could say, well, statements could either be more than one statement, or it could be a single statement. You'll notice there's like two functions with the same name there. Okay, a little disturbing maybe. Okay, and then you kind of fill this thing out. You say, well, okay, this statement with ID expression, that's basically one statement. You'd have print. Okay, so you're defining two statements there, like that. And you kind of continue through the whole, the whole thing here. It's we'll if you want to do expressions, I've only got like 5 minutes here, so must type faster. Okay. So it looks a little different, but it's kind of the same idea. I'm not going to do the grouping, just in the interest of time here. Okay, so you start off, you basically do your grammar like that. Okay, so you have a bunch of functions like that. In those rules, you're going to do the same kind of thing that you did in the last example, but it's going to look a little different. You'll say, well, this is like an ID where you have PID, and this is a number where you have sort of the number value there. This is going to return a tuple, or the values of the tuple are the operator, and then you have like the expression on the left and the expression on the right. This might look a little weird, by the way. This is basically trying to disambiguate the two expressions in there, and the syntax for that is mirrored after what is used in compiler books. So it's meant to mirror what's in the textbook, actually. Okay, so kind of continue on here. We're almost done. Famous last words. Okay, so now I'm really in trouble at the hearing the applause in the other room there. Okay, so you basically do that. And if I've done this right, which statement, yeah, okay, good, okay. We should probably put some precedence rules in this as well. It does need to have an opening bracket on there. Okay, so if we've done that, well, okay, not quite yet. It does need to know what the tokens are. Okay, so you do have to teach it that. Okay, let's try it out here. So what you're going to do is basically parse something. You have to give it kind of the token list, like that, and you have to spell it right. Okay, so you're supposed to know what I'm doing. You'll basically get back your parsed output. Now we're basically at the end of this thing, and really the point of this talk is not so much that. I mean, it's like, okay, it's parser generator. I think the interesting thing here. Oh well, there are some downsides. Let me get to the downside here. If you do this, you're going to break the universe, by the way. I mean, this slide tool breaks PyCharm, pep8, PyLint, MyPy, probably the whole universe. I sort of thought about, like, how would I defend myself against that? And I don't know. I think the interesting thing here is that talk on Spark that I saw like 20 years ago. I thought that was so awesome, where it's like, oh man, he's like totally abused Python in this like horrible way to do this cool thing with parser generators. And what's happened in Python 3.6 is that they've given you all these like new knobs to turn. Like it's like, okay, you have like ordered, Guido's going to regret making dictionaries ordered probably after this talk. Then no, it's like you have ordered dictionaries, you have all this way to monitor subclasses, and you've got this like metaclass stuff going on, and type hints and stuff. There's some really interesting stuff you can do with those that like take like that docstring thing from 20 years ago and just push it into like a whole different space-time like dimension, basically. And I think there may be some interesting things there, like for certain kinds of problems, it might be really cool to kind of play around with that. I've been kind of dealing with this with the parser generator, and I've been doing this in some compiler classes and stuff. It's really cool. I mean, it's super magical, maybe too magical, but it is. There's some interesting things there. So kind of hoping that maybe it will inspire some student or something to go run off and get fired or something. Okay. So anyway, so that's the end of the talk. Follow me on Twitter. Do we have any time for questions, or are we like out of time?
Thanks, David. We have time for a couple questions, so if you'd like to ask one, step up to the mic. We ask that you only ask one question. And
one question, okay. All right, thanks. Is there, so no, that people are too stunned for a question? Oh, there we have one question.
Hey, David. I saw on the parser, the tokenizer class, that it referenced all the tokens before they were actually defined. Was that, how come it's not a name error? Was there some metaclass there or something?
You can do anything with metaclasses. Yeah. I mean, that might, actually, I want to make a comment about that. One of the reasons why it does that is I have run into lots of problems in classes where people will put quotes around stuff, like let's say it's quoted, like that, and then they'll hit return in the middle of a line or something, and not realize that they have an error in the code. I don't know whether people can even spot the error there. The error is that Python concatenates adjacent strings. Like if you miss a comma or something like that, you get like adjacent string concatenation. I was sick of dealing with it in teaching classes, and I was like, you know what? You can't concatenate adjacent identifiers. Like if you forget the comma, you'll actually get like a syntax error in Python. So now it might look kind of crazy, but it was actually done to address like a very specific usability problem and like using it. So.
Hi, thanks for the talk. We're big users of Ply, and I'm wondering if there's any advantages for me to convert all my code to the new version, like speed improvements, stuff like that.
Well, the main advantage is that you can drop every version of Python prior to 3.6. So yeah, that is that. Aside from that, no, I think I actually like Sly a lot better because one of the problems with Ply is there's way too much weird hacking with there's this cached output file, and like it does all sorts of weird things like writing things on the file system, and causes a lot of problems with like deployment and other things. And it's like I've tried to just get rid of that. Like it's like, okay, this is a new thing. Like let's just get rid of all this junk from when I had like my 200 megahertz PC and just like modernize the thing. It does have the feature though. It does require Python 3.6 though. So.
Hey, so apart from like the fun of abusing all the language syntax, like if you actually had to write a language, would you actually like use this, or would you like recommend something like PyParsing?
No, people use this to write languages. I would look at PyParsing too, though. I mean, it's a different approach. So I mean, there's different tools out there. I mean, Antler is another tool that's out there. I forget, is it Eric Snow that has the PEG parser? I'm forgetting the name of his project off the top of my head. But no, there's a lot of tools out there. I would definitely just look around at tools, especially compared to writing it yourself by hand, like doing a handwritten parser. That's a really like tough slog to get through that. So I would definitely look at the other tools. So.
All right, thank you, David.
Okay, thank you.